Let's be real, when we talk about climate change, predicting the rain is a whole lot more than just figuring out if you need an umbrella. We're talking about protecting lives, entire economies, really our future. And guess what? A brand new research paper has just dropped a model that promises to do exactly that, with some pretty stunning accuracy. So let's dive in and see how they pulled it off and what it means for all of us.
All right, here's our game plan. First, we're going to tackle the big problem, why forecasting is so tricky. Then, we'll get into how researchers built a better model using this really cool 6-step recipe. After that, it's the main event, an accuracy showdown between the new model and the old one. We'll even see what these predictions look like on a map and wrap it all up with why getting this stuff right really, really matters. Okay, so let's jump right into the heart of the challenge. I mean, we all feel it, right? The weather is just getting more and more extreme. But if you're a farmer or a city planner, the biggest headache isn't just the extremity, it's the sheer unpredictability of it all. And that brings us to the million-dollar question. Can we actually see what's coming with any real accuracy? Because, the answer to that question changes everything, from the food we eat to the safety of our communities. Because the stakes here are just incredibly high. The paper lays it out perfectly. Not enough rain, you get devastating droughts. Too much rain, and you're dealing with floods and landslides. And these aren't just headlines, right? This stuff directly hits agriculture, public health, fishing, even tourism. It affects real people, real livelihoods. So, to deal with this massive challenge, a team of researchers basically asked, can we build a better tool? Something that could slice through all the noise of this super complex climate data and give us a much clearer picture of what's ahead. And they zeroed in on this specific type of model called GSTARIMA. Now, don't worry about the name, you're not going to be quizzed on it. All you really need to know is that this thing is specially designed to handle data that changes in two ways. Over time, think seasons or months, and across space, like different cities or regions. So the researchers basically set up this epic showdown. In one corner, you've got the original, the established, simpler model. And in the other corner, their new, souped-up upgrade. Their bet was simple. By making the model more complex, it could capture more of what's actually happening in the real world, and that would lead to a way more accurate forecast. But, how do you even start building something like this? I mean, we're talking about massive climate data sets, stuff from NASA. You can't just wing it. You absolutely need a structured process, a recipe to follow. And that recipe is the 6-phase process called the data analytics lifecycle. And the first thing you'll notice is that it's a circle, not a straight line. That's so important because it means you can always go back a step, refine things, and make the whole process smarter as you go. So here's how that life cycle works in practice. You start with discovery. What's the problem we're trying to solve? Then you get to data prep, which is all about cleaning up that messy data. From there, you plan and build your model. You figure out how to communicate the results, usually with cool visuals. And finally, you operationalize it. That's just a fancy word for putting your insights into action in the real world. All right, and that brings us to the moment of truth, the accuracy showdown. After all that prep work, it was time to put the two models head-to-head and see which one could actually predict the rain better. The test they used is called mean absolute percentage error, or MAPE for short. And honestly, the rule couldn't be simpler. The lower the score, the better the forecast. It's just a really clean way to measure how far off your predictions are from what actually happened. And the results were crystal clear. The old model? It came in with an 11% error rate. Not bad, but the new upgraded model, it scored just 9%. That's not just a little better, that's a decisive win for the more complex approach. So yeah, the winner by a knockout is the GSTARIMA 311 model. This totally proved the researchers' hunch was right. Adding that extra layer of complexity allowed the model to really understand the patterns in the climate data. But you might be wondering, how good is 9% really? Well, check this out. According to the scale everyone in the field uses, any score under 10% is classified as highly accurate forecasting. So this isn't just a tiny improvement we're talking about. This is a leap straight into the top tier of forecasting performance. It's a huge deal. Okay, so we know it's highly accurate on paper, but what does that actually look like? Let's take a peek at the actual forecasts this model spit out. So the study focused on data from NASA, covering 11 different spots across West Java province in Indonesia. You can see them marked there on the map with those little green dots. All right, take a look at the forecast for December 2022. The model painted a really clear picture. See those warmer colors?
That's where it predicted the heaviest rain, mostly up in Indramayu. Meanwhile, places like Bokassia were looking much, much drier.
But now watch this. Just 1 month later, in January 2023, the whole pattern flips. Now, Bekasi City is the one getting slammed with the most rain. This is what makes the model so impressive. It's not static. It can capture these incredibly fast, dynamic shifts in the weather.
And then, by February, the pattern almost completely inverts. Indramayu, which was the wettest place in December, is now forecast to be the driest, and Bekasi is still getting a lot of rain. This shows it's not just a snapshot, it's a model that truly gets the complex dance of regional weather patterns.
So, we've got a super accurate model, and we've seen what it can do. But let's bring it all home. What does a breakthrough like this actually mean for us in the real world?
While the impact it's huge, a model this good can act as a true early warning system. It can give communities precious time to prepare for floods or droughts. It hands government agencies the kind of solid data they need to make smarter decisions. Decisions that, at the end of the day, protect lives and our critical infrastructure.
And this really hammers home the main point from the researchers themselves. They said, and I'm quoting here, selecting the correct order is crucial for the model's accuracy. What they're saying is getting the complexity right isn't just some nerdy detail. It's everything. It's the key to making a forecast that's actually useful.
Look, this research is a massive step forward. And it really makes you think, right? If we can now predict something as chaotic and complex as regional rainfall with this kind of precision, what's next? What other parts of our changing world will we be able to see coming?